Bismillahirrahmanirrahim. Hello, my dear students. How are you? I hope you are fine and enjoy good time and good health. Today, inshallah, we will resume talking about mathematics of finance with compound interest, rescheduling payments, or equations of value.
The formula for amount future value equal present value times 1 plus I to power n, and the present value equal the future value times 1 plus I to power negative n. So to get I'll subtract future value minus present value by substituting for FV equal BV times 1 plus I to power n in formula I equal FV minus BV. So I will be equal BV times 1 plus I to power n minus BV, taking BV as a common factor, then I equal BV present value times 1 plus I to power n minus 1. Let's start with problem number 1. In this example, or in this problem, find the value of x. We know that to solve the types of these problems, we need to know the position of focal date. And there are 3 positions of focal date. The first, if focal date lies before the maturity dates of old and new obligations, then the present value of old obligations equal to the present value of new obligations. The second, if the focal date lies after the maturity dates of old and new obligations, then the amount of old obligations equal to the amount of new obligations. And the third, if focal date lies in between the maturity dates of old and new obligations, so the amount of sum of old obligations plus the present value of the others equal to the amount of new obligations plus the present value of the others. In this problem, the focal date lies in before, so we will get the present value. The present value of all the obligations, $15,000, and the present value for $40,000 equal to X. And because of J equal 8% compounded semi-annually, so M equal to I equal 8% over 2 equal 4%, and I for $15,000, M for $15,000 equal to 3 years times 2, which is equal 6, and the time for $40,000 equal 5 years, so N will be equal 10. Note that N for X equal 0 because of the time of X, the distance between the maturity date and the focal date equal to 0, so N number of adding benefits equal to 0. The solution: J equal 8%, M equal 2, I equal 4%, N equal 6, and M for $15,000 equal 6, M for $40,000 equal 10. By substituting in formula, present value equal future value times 1 plus I to power negative n, so X will be equal $38,000 $877. Problem number 2. If money is worth 6.5% compounded semi-annually, find the value of X. In this problem, the focal date lies in between the maturity dates of old and new obligations. So, for the old obligations, we will take $5,000 at its value, and we will get the present value for $12,000. And for X, we will get the future value. So the main formula here equal $5,000 plus present value of $12,000 equal the amount for X. In other way, O1 plus BO2 equal SN. You can exchange B by present value and S by future value. Solution. Where is J equals 6.5% and it is semi-annually, so M equal 2 and I will be equal 6.5% over 2 equal 3.25%. N for X, the time for X equal 2 years, so N will be equal 2 times 2, which is equal 4. And the time for $12,000 equal 2 years, not 4 years, because of we get the distance from the maturity date to focal date. So N will be equal 2 times 2, which is equal 4. By substituting, we will get the value of X, which is equal 13,690. Problem number 3. If money is worth 11% compounded semi-annually, find the value of X. In this problem, the focal date lies after the maturity dates of old and new obligations. So, the value or the amount of old obligations equal to the amount of new obligations. So, S for $4,000 plus $5,000 equal to the future value for X. The future value for $4,000 plus $5,000 equal the future value for X. In this example, because of the nominal rate J equal 11% and it's compounded semi-annually, so M equal 2 and I equal 11% over 2 equal 5.5%. And M for $4,000 equal to, because of the time here 1 year, M for $5,000 equal to 0 and N for X equal 4. Solution. X will be equal 7,629. Problem number 4. If money is worth 9% compounded semi-annually and the focal date after 18 months from now, find the value of X. In this example, the focal date lies in between the maturity dates of old and the new obligations. So the future value of some of old obligations, $6,000, plus the present value for the others, $9,500, equal to the future value for sum of new obligations, which is equal X, the future value for X, and there are no any other new obligations. In this example, J equal 9%, so I equal J over M, and because of M equal 2, so I equal 4.5%. Solution. I equal 4.5%, N for X equals 3, note that the distance between X and the focal date 1.5 years, 18 months. In 18 months there are 3 periods. Every period equals 6 months. So the interest will be added 3 times. And M for $6,000 will be equal 1. The distance equals 6 months. And for 9,500 will be equal 1. By substituting in formula, future value equal present value times 1 plus I to power n, and present value equal future value times 1 plus I to power negative n. X will be equal 13,460. Problem number 5. Given money is worth 7.5% compounded annually, and the focal date after 4 years from now, find the value of X. Also, in this example, we will exchange one old obligations, $3,000, $30,000, with 2 new obligations, X and 2X. And because of the focal date lies in between the maturity dates of old and the new obligations, the future value for $30,000 equal to the future value for X plus the present value for 2X. In this example, J equals 7.5% and it's compounded annually, so I will be equal 7.5%. And N for $30,000 equal 4, N for X equal 2, N for 2X equal 1. By substituting for I equal 7.5% and N equal 2, N for 2X equal 1, N for $30,000 equal 4, N for X equal 2. X will be equal 13,283. Problem number 6. Given money is worth 11% compounded annually, find the value of X. In this problem, we didn't know the position of focal date. He didn't determine the position of focal date. So the best position for focal date is after 3 years in the position of X. To reduce the formula we need, and the main formula will be the amount of old obligation, $18,000, equal to X plus the present value for 2X. Note that the nominal rate equal 11% and M equal 1 because of its compounded annually, so I equal 11%. And you can easily get N for $18,000, which is equal 3, and N for X equal 0. Finally, M for 2X equal 2. J equal 11%, M equal 1, I equal 11% over 1 equal 11%, M for X equal 0, M for 2X equal 2, M for $18,000 equals 3. By substituting in formula of future value equal present value times 1 plus I to power n, and the present value equal future value times 1 plus I to power negative n, you can get X, which is equal 9,384. This is the last example for now. See you next time, and thank you.